In this lesson, we'll explore the first of our special quadrilaterals, which is the trapezoid. Not only will we look at some properties, but we'll also get right into writing some proofs. So first of all, what is a trapezoid? A trapezoid is a quadrilateral that has at least one pair of parallel sides. Now note the definition for trapezoid. In order to be a trapezoid, you have to have at least one pair. That means you could have two pairs of parallel sides and still be a trapezoid. Now, in the event that only one pair of sides is parallel, we call the parallel sides bases and the non-parallel sides legs. So if you look at the picture of the trapezoid that's given to us, the bases are the two horizontal pieces and the legs are the non-parallel, non-horizontal sides. Now the median, which is sometimes called the mid-segment in a trapezoid, runs parallel to both of the bases, and it has length equal to half the sum of the lengths of the bases. Or in other words, another way of saying this might be to say that the median or mid-segment has a length that's equal to the average of the two bases. So here they've used the 1/2 rule, so the length of median mn is equal to 1/2 the sum of the two bases. Another way to say this might be to say that the length of mid-segment mn is equal to base DC plus AB all over 2. So that's kind of two different ways in which you can think about the same idea. The definition that we have for isosceles trapezoid is a little different than the one that we have for an isosceles triangle. We say that an isosceles trapezoid is a trapezoid that has congruent base angles. So anybody that has congruent base angles, or any trapezoid that has congruent base angles, is automatically an isosceles trapezoid. Now the base angles would be the angles that are attached to the bases. So in the picture, angle D is a base angle, as is angle C. Angle A is a base angle, as is angle A. Now, once a trapezoid is isosceles, some characteristics that it possesses is that it has congruent legs. So if these base angles are congruent, then it must mean that the legs are congruent as well. So leg AB would be congruent to leg, that's leg AD would be congruent to leg BC. And again, once the trapezoid is isosceles, another property that we can say it possesses is that the diagonals are congruent. So one of the diagonals of this trapezoid would be diagonal AC. The other diagonal of that trapezoid would be diagonal AB. So again, once the base angles are congruent, we know that diagonal BD is congruent to diagonal AC. All right, so that's a lot of properties to take in. Let's pause and take a minute here and go look at some examples of how we might use these properties in order to solve some problems. In this first example, we're given a trapezoid ABCD and we're told the measures of a couple of its angles. And we're asked to find the measures of the remaining angles. One thing I want you to note is that this trapezoid is not necessarily isosceles. If this trapezoid were isosceles, our job would be easy because all of the base angles would be congruent, but this trapezoid isn't given to us to be isosceles. But what we do know is we know that the bases in our trapezoid are parallel, and if we consider the legs in our trapezoid to be kind of like a transversal, these same side interior angles we remember from our knowledge of parallel lines have to be supplements. So the supplement to 78 would be 102, making that first angle 102. And if I consider this green leg to be a transversal over on the right side of my trapezoid, the same side interior angles on the right, or the green transversal, also need to be supplementary, making this angle up at the top of my trapezoid 48 degrees. So all of the properties that you remember about parallel lines will also work with your trapezoid because two of the sides of the trapezoid are really parts of parallel lines. In this last example, we're given trapezoid star with midsegment MN, and we're asked to find the value of x. Now, always, when I'm dealing with a problem that involves the midsegment, I always write the formula first. Once I put the formula down on my paper, it's only a matter of substituting or plugging into that formula. So I know that for any problem that deals with a median or midsegment, the length of the median or the midsegment is equal to the average of the lengths of the two bases. So in other words, the length of midsegment MN is equal to the sum of ST and RA divided by 2. Once I get that formula written down on my paper first, now all I have to do is go and substitute into that formula. So in place of midsegment MN, I'm going to replace that with the number 19. In place of the base ST, I'm going to put 4x subtract 7. And in place of the base RA, I'm going to input 6x plus 5. And all of that is divided by 2. I'm going to go ahead now and clean up the numerator on the right side of my equation. So when I combine like terms, I end up with 10x subtract 2 over 2. And then since I have a fraction on the right side but not on the left side, I'm simply going to put that 19 over 1 so that I can go ahead and cross multiply. So going in the first direction, my cross product is 10x subtract 2. Going in the other direction, my cross product is 38. And from here, it's a relatively straightforward process to go ahead and to solve for x. Once I do that, I find the value of x to be equal to 4. But again, getting that formula down on paper, getting that formula down first, is really the secret to my success in approaching any problem dealing with the midsegment. All right, so that's how you might use some of those properties in problem solving. We do have to talk a little bit about how or methods in which we could prove that a quadrilateral is a trapezoid. Remember that a trapezoid is a quadrilateral that has at least one pair of parallel sides. So if we can show that our quadrilateral has at least one pair of parallel sides, it automatically gets to be a trapezoid. If we're working on the coordinate grid, the way that we're going to show that something has a pair of parallel sides is by showing that they have the same slopes. Once we've shown a quadrilateral to be a trapezoid, we can show that it's isosceles by using one of the two following methods. We can either show that the trapezoid has congruent base angles. Now, when you're working on the coordinate grid, it's very difficult to show that something has congruent base angles. Or we can show that the trapezoid has congruent diagonals. And when working in the coordinate plane, it's considerably easier to show that something has congruent diagonals. We can show those are congruent simply by using the distance formula. So let's go ahead and let's jump into this example. It gives us the coordinates of quadrilateral ABCD, and it asks us to prove that that quadrilateral is indeed an isosceles trapezoid. I'm going to begin this problem by plotting the points so that I can get an idea of exactly what I'm looking at here. So there's ABCD, the quadrilateral that I've been given to work with in this problem. And I want to first show that this is a trapezoid. I'll worry about the isosceles part in a minute. Remember, in order to be a trapezoid, you need to have two pairs of parallel sides. So I have a couple of choices here. I can either use my slope formula to show that they have the same slopes, or because I've drawn the graph, I can use the graph in order to find the slopes. So in looking at my graph, the slope of segment DC is going to be rise over run, or in other words, 0 over anything I want. I could make that 0 over 7, but 0 over 7 is just 7. I'm sorry, 0 over 7 is just 0. And then the slope of my other base, AB, is also going to be 0 over some number. But when I divide 0 by any number, I end up with also 0. And because these two have the same slope, I know they have to be parallel. I am going to put a little note on my paper that I obtained these two slopes by using the graph, so that anybody that's reading my work can follow along and they'll know exactly where those slopes came from. So now segment AB and segment CD are parallel since they have the same slope. And this is going to make ABCD a trapezoid. Since it has one pair of parallel sides. So now that I've shown that this fellow is a trapezoid, I now want to go and show he's isosceles. And again, congruent base angles in the coordinate grid are pretty difficult to do. So I'm going to show instead that the diagonals are congruent. And the way that I'm going to show that the diagonals are congruent is to use the distance formula. So with any other formula or with any formula, the very first thing I need to do is get it down on my paper. And one of the diagonals in my picture is diagonal DB. So I'm going to identify to the person reading my paper that diagonal DB is the diagonal for which I'm finding the first length. Remember that when you substitute into the graphing calculator, you are not going to use the radical, but rather you're going to begin with the open parentheses. And we find that the length of diagonal DB is equal to the square root of 100. But a more eloquent way to say the square root of 100 is just to say that the length of diagonal DB is 10. Now that I've found the length of diagonal DB, I'm going to go find the length of the second diagonal, which is AC. And again, I'm going to identify that on my paper so that whomever is reading my paper knows that the segment for which I'm finding length is diagonal AC. And again, when I substitute or plug into my calculator, I'm going to not plug in the radical, which means my answer is still under the square root symbol. But when I plug in everything under the radical, my calculator tells me 100. And again, a classier way to say square root of 100 is just to say 10. So now I've shown that this trapezoid has congruent diagonals, and that in turn makes my trapezoid isosceles. So I've got to write a little blurb explaining why I did these calculations that I did and what it is that they show. So this trapezoid is isosceles or I can say this trapezoid has congruent diagonals, making it isosceles. So this lesson contains a good little amount of information regarding the trapezoid and the proofs. As always, thank you for the gift of your time, and I do want you to take a few minutes and just think about what you saw, think about what you heard, and summarize in your own words the key understandings and important takeaways from this lesson.